Hey, good morning. So today we are going to another section in chapter 10. We are going to talk about power series. So in the previous lecture in 10.2 till 10.6, we got many tests, each one used for its place. For example, some of them alternative, some of them geometry, some of them power, P series, and we have many. Today here we have a power series and convergence. What's the power series? We have two formula for power series. We have Cn, generally we say Cn, Xn. Now we have n and x, you can see. Now n from 0 to infinity. From 0 to infinity. Thank you. Okay, from 0 to infinity. And if we put a 0, we will get what? C naught, right? X naught plus C1 X1 plus C2 X squared and go on. So generally you will get C naught, C1 X1, C2 X2, and go on. You can see from here till where? Till infinity. Or nth term, you can say Cn Xn and go on. This is the special case and called power series. As well, we have another case, general case. We have what? We have power series about x equal to a. When we say that x equal to a, we have such form like that. We have series of 0 to infinity, means that n from 0. Again, Cn, instead of just xn, we have x minus a to power n. So again, we will get what? When n is 0, I'll get 1. So I'll get Cn C1 x minus a to power 1 plus C2x minus a to power 2 and go on. So here we are, you can see from here. This is the second formula, which is the general formula. When a is equal to 0, you will get the first one, right? You can see. This is the general formula. When a is equal to 0, I will get the first one. Am I right? So we cannot see we have two formulas. No, just we have one formula, but that one is a special case. When x is equal to what? X is equal to 0 here. Or you can say, sorry, a equal to 0 here. And the second when x equal to a. That's called a series. Okay. We have two cases of power series. Geometry power series, so we have power series. Geometry power series and others. The geometry power series, like a previous one, there's R. How? For example, we can see from example 1, xn. You can see if you expand or if you give the value for n, you will get something like a geometry. N is equal to 0, I will get 1, x squared, and go on. Am I right? You can see there exists R here, R here, R there. R equal to what? X. Am I right? X for sure. So we say that geometric power series is converged. Where? Can you tell me? Like a geometry. We see if R, right, between 1 and minus 1. Am I right? R between 1 and minus 1. Now R changed to what? X. Easy. So we see that series, a series is X between 1 and minus 1 is converge. Otherwise, diverge. You got it. Now, before that one, instead of that one, you have that something like that. You say 1, 1 over 2, 1 over 4, right? We say R equal to number. We specified the number. But here, no, we don't specify any number. Generally, we have x. So we decide x should be equal to what? So here we say x should be between 1 and -1 in the previous example. Our geometry, now we have a power. We have a power. When you say power, yes, power is general case. Good. So you can also see the solution place, the location of the solution here. Am I right? I'm done. Easy. The first part is easy. Okay. So here we are. You can see from here, you can see the solution. Understood? Good. Now, I think it was here, I don't know, in that section of in the section number 2, they asked me why we need series. What's the application of series? You have a report, right? So you need to present something with the application, deal with that one. One of the applications is that. One of them. How to use the series to approximate the solution. What do you mean? For example, that's not just for information, okay? From now is for information. If you have a equation like that, you see x is equal to, the solution is what? Right? This solution is exact. If you put 1 here, you will get what? 100%, you get 0, right? How about that one? If you put 1 or -1 here, 100% you'll get 0. So that's called exact. Also, we have a solution for x to power 3 and x to power 4. We call Kardar and Ferrari. They put a method to find the solution. But when we have x to power 5 plus 4x to power 4 plus 5x to power 2 minus 2 is equal to 0, we cannot solve exact solution. We cannot get exact solution. So from x to power 5 to up, there is no exact solution. Okay, maybe by chance, yes, but generally there is no method to solve it. So in that case, if we don't have an exact, okay, we try to find approximate. Approximate like what? For example, if I have x minus 1, you know the exact is what? X equal to, what, am I right? How about if I put 0.999 minus 1, I'll get what? Minus 0.001. Am I right? So I'm close to 0. I'm close to the exact solution, but I have an error, right? It's not exact, but it's like we can say approximation solution. It's not exact. That one is called approximate. Okay, you got it? So approximate. To find, actually, this is very important for you, especially when you need to get a master's degree. You need to have an idea about that, something like that. When I say master's degree, not in math, in your, okay, in your specialty, because you need some approximate things. So when we say approximate solution, we have an error. And when if your error is less, means that your method, your solution, your approximation solution is better. For example, if your friend finds something like that, 10 to power minus 5, and you find something 10 to power minus 6, yours is better. You know, because you're closer to the approximation solution. You are closer to the exact solution. So that's called approximation. Okay. To find the approximation, we have many methods, many. Unbelievable. We have maybe 1,000, 100, I don't know. We have many. So the beginning, to understand how to find or how to create a new one, you should at least review some of them, right? So one of the method is what? Is power series. One of them is Tyler. Talent is very, very famous. It's very, very familiar. It's very, very famous, and it's very useful. One of them. So if you don't understand about power, you don't have information, you cannot understand the approximation, and you cannot understand Taylor and the rest methods. So that one, when we see power, we can see, for example, I try to find the solution of that. Or find, sometimes we call roots. Because if you have an equation, we say equation and solution. But when you have f of x is equal to x minus 1, you have function, and we have roots, called roots. The solution of here is called roots. Okay, so the concept. So I have this function, and I want to find the roots. Like equation, I want to find the solution, the same. So how I find the 1 minus x? How about how to solve that one? X is equal to what? So we cannot say x is equal to something, right? So how we find that one? How we say that one is equal to 0? How we find value of x? We approximate. First of all, we say y be 1. What do you mean by 1? 1 plus x? 1b plus x. What do you mean by that? We know in power series, we say that the first term is what? 1, right? How about the second term? So I say, this will be my first attempt. Let be the first attempt, first term, be my solution or roots for my function. Okay. So I see y equal to 1. How's the graph? You know, y equal to 1, right? So this is my solution. But where's my equation? Here's my equation. You can see. My equation is like that. Before finding the solution, here's my equation. And I try to find the solution. So the first solution is like that. Do you think that one solves that one? No. Why? Because I have an error. I have a bunch of error. I have a maximum error, right? So this means that one step is not enough to find the approximation solution. So we are going to do what? We are going to do another term. We say let be what? Another term. After 1, I will get x, right? So now my function changed to 1 plus x. 1 plus x is like what? You know. It's like that. Understood? We use another color. So this is the graph of 1 plus x. That one is better than that one, right? The second step, the second term, when I take 1 plus x is better than the 1, just 1. So it means that I am close to the solution, but still, what? We have an error. So I'm going to another step. I say, let me add another step. How? I say I'm going to, for example, add another term. I'll get what? X squared. And I know 1 plus x squared, the graph is like what? Squared. It's like a U. So you can see from here. You can see from here. This is a little bit curved, a little bit. So for here, a little bit curved. It's good, better than the green and the, what do you say, black, but still I have an error. So I'm going to add another one and go on. So when I am going to use many terms, I'll be closer to my graph. For example, after, if you are, especially when you are using the computer, we say computation, okay? We have more iteration. Iteration means that x squared, x squared. And if I use these iteration, many iteration, for example, if I say I have 1x squared till x 100, okay? X to power 100 or 1000. So I will be closer to, very close to here. I don't get 100% the solution, but I closer to the curve that I have. So this is called approximation. And you can see that iteration came from where? From power series. So that's why power series, one of the application of power series is to find the approximate solution. You got it, Jamaat? It was about application. For more research, for more information, you can search and you can visit many websites. They will give you many idea about it. Another example, I have what? 1/2 x minus 2. Okay. For example, if I have 1/2 x minus 2 to power n. So when you saw x, think about what? Power series, because you have x. So I'm asking myself, is from geometric power series or the others? That's what you need to explore at the beginning, okay? To find. So how do we know? How we check that one? I'm going to substitute and expand. How? By substitution n. So if I put n 0, I will get what? 1. I will get what? 1. Am I right? If I put n to be 1, I will get what? Minus 1/2 x minus 2. Am I right, Jamaat? N to be 3, I will get what? 1, 2. Am I n1? Yes, n to be 2, sorry. And go on. So tell me about, is that one geometry or not? Hello? A geometry or not? How do you know it's geometry? How do you know it's not? By R. So how we get R? Okay, so how do you find the distance? Yalla, go on, answer. You are right. Divide it, right? Divide them, yalla. If I divide that one by that one, I will get what? Am I right? Well, if I divide by that one, I will get what? Dividing minus 1/2 or بيستودوني 22 2 to power 2. Am I right? Okay, that one with that one, that one with that one. So it remains what? Understood? So they are the same or not? Same, yes. So we have R. Again, we have R. So between 1 minus plus x minus 2 minus, there's R. And R equal to what? So tell me about the convergence and divergence, because you have x here. So we have two options, maybe converge, maybe diverge. So I say whenever 1/2 x minus 2 between 1 and minus 2, otherwise, so find the value of x, multiply by 2. Am I right? Jamaat? Then x between, you got it? This is the convergence region. Understood? Means that if I put any value, for example, if I put 1, 2, 3, any value in here, instead of x, if I put any value here or here, any value here, for example, if I put 1, 1, 1, I will get what? I will get converge. If I put 5, I will get what? Diverge. Why? Because this is the convergence region. So 5 make it diverge. But 4, between that one, if I put any value there, I'll get what? I'll get the converge. How? For example, we say let x be 1. I'll get what? We say minus 1 over 2 to power n, right? So we have what? 1 minus x minus 2, whenever. So instead of x, I put what? 1 to power n. You got it. So it remains what? So I put minus 1 to power n. 1 year later. So you'll get minus 1 to power n. Okay, so minus 1 minus n, I will get what? Minus 1 2n over 2n. So tell me about the r. اگه بی که تو ترمگان چند داره چیه؟ n0 به 1 1 over 2 1 over 2 square 1 over 2 to power 4 3 and go on. So r اکی بو بچن؟ Converge and no. So if you choose any value between 0 and 4, you'll get converge. Otherwise, you'll get diverge. Put 5, you will see you'll get diverge. Understood, Jamaat? Good. So here we are. Here's the series. Here's the R. And here's the solution of, or the region of the solution. And it's called about the approximate and things that you need to find. You got it, dear? Do you have any question? This is the first part of the power series. Any comment? Comments? No comments? Like? Okay, thank you. Share? Okay, don't share. It's okay. Good. So this is about first part of power series. But the other depends on the techniques. And after technique depends on checking. And after check, you decide converge or diverge. So we have many steps. So in the exam, during the exam, if it's a geometry, you don't need anything. Just find the R and decide where is R. So mostly you'll get inequality. What do you mean by inequality? This is the inequality. That one is inequality. Understood? Ama inequality. La sanga. So in the geometric power series, you will get the inequality. And we don't care about the boundary. We don't care about the numbers, the limit number here and there. For example, between 0 and 4, we don't care. In the previous example, we had 1 and minus 1. We don't care about 1 and minus 1. We don't care. We don't see anything. We see it's exclude, right? It's exclude, is not include. But in the other type, no, we should test. Then we decide. Good. So here we are. I'm going to the other side. So power series. We have geometric power series done. Now we are going to the other. اگر هاتو geometry كيبو اگر geometry بس يخواني. You got it? Good. So if it's not geometry, for example, xn over n minus 1. Look. Now I have power series. I'm 100% sure. How? Because I have x, right? But is geometry or not? That's the question first. So you should expand the term to understand, to recognize it. So if n is 1, I'll get what? Right? If n is 0 or 1, let me see. n1, so I'll get what? Right? If n is 2, I'll get what? If n is 3, you'll get 4. Let me go on. Tell me, is geometry or not? Where's the problem? Yalla. Geometry or not? Just divide it. No, why? Because I'll get the problem, it's not with the x. It's with the denominator, right? The denominator make a problem. So there is no r, right? So there's no geometry, but it's power series, of course. So it's other. So how we solve the other? We have two techniques. I'm telling you one of them, the other for you. We can use absolute ratio test. Absolute ratio test. Do you remember that? Right? We are going to use absolute ratio test. How? Let me apply it. I say n approach to infinity, absolute value. Where is xn? An? That one, right? Because we have absolute value, I'm going to neglect that part, okay? We don't need to. Understood, Jamaat? I have what? Xn over n, xn plus 1 over n plus 1. Am I right? That one, an plus 1, and that one, an. I'm use the absolute value to remove, to cancel that minus, negative. This is a technique. Okay, so is equal to what the limit? Yalla. Equal to what? Xn plus 1 over n plus 1 multiply n xn. Am I right? Onya? We will get a reciprocal. Understood? Good. And I know xn, it can be written as x. Right? Hello? So that one is removed. It remains what? X. So I'm going to cancel n with that one. And I will get what? Only x multiply n plus 1. Do you have any problem? Okay. So I have a question. Can I do like that or not? What did I do, Jara? Tell me. Okay. Yalla. She is right. Okay. How about if I say she is wrong? She is wrong. Okay, why? We don't know. X is variable. Why? Okay, so we cannot take in also variable. No, it's not x, n. Exactly. Because so because the limit deal with what? Just we care about n. So if I take n to out, I did the kafir, right? It's taboo. But when you say x to out, it's okay. Because x like any constant, any things. It's variable, yes. But do not deal with what? With the integral. For example, if I have integral of y x squared dx. Now my problem is what? With x, so I can bring x out, y to out. You got it. Understood? If I have a limit of x, y, when y approaches to 0, for example, in that case, x is constant, you know. We don't care about that one. So the same thing is true for the previous one. So that's why, yes, we can bring it to out. Okay, this is the first. And I'm going to remove that one. Am I right or not? Why? Right or not? Why? You are right. But I canceled. I deleted. Why? N is positive. So N positive. Positive over positive, positive. Plus 1, again positive. So we do need the absolute value. The same value. Good. So it remains what? And tell me about the value of this one. Yalla. The value of this limit. 1 over 1, right? Why 4? So it remains what? Am I right? Was equal to XA. We got X. Do you remember in? Of course you remember because you have a quiz. You should know that. So do you remember about ratio test? The outcome of the ratio test is what? We call what? Rho. You are al-mim, you see some Greek letter. Thank you. So it's equal to rho, right? So you see where's convergence of rho? Rho is what? Less than 1 or equal. Okay, so here, compare with 1. Okay, say like a R. Okay, you can see R again. Now I'll tell you why. Here, say or compare the value, say between or say less than 1. Am I right? Understood. We say when we have a ratio test or root test, we say we have rho, and rho for convergence should be less than 1. Okay. But here, absolute value. When absolute value is less than 1, I remember in 10.1, theorem number 5, we got something like that. You see, means that what? X between what and what? No. Minus 1 and 1. You should be careful, okay? So this is called the absolute value and inequality. Did you understand, Jamaat? This is the first example, need work actually, but the second and third are the same strategy, and you'll deal with that one. You'll be more faster. Yalla. So we got half of the solution. Yes. Okay. We have two rules. Okay, thank you. If you have inequality and we have absolute value, we have two rules for any value. When is absolute value less than the number, you say X between positive and negative. Yes. This is the general form. If X greater than number, you say X greater than A or X less than minus A. This is the rule. In calculus 1, actually, you should take that one, but we remove it because the book remove it and make that a preliminary. You see, it's easy. They took that one in the high school class, so they deleted in the last edition. So this is the rule. Okay, when you have absolute value, you have two rules. An absolute value with inequality. Understood? So but here usually we use the less. That's why I'm not mentioning the other. Okay, when it's less than 1 means that between 1 and minus 1. You got it? For example, just for more information, extra to here. For example, I say X minus 3 less than 2. So how we deal with that one? How we expand that one? Okay, we say X between 2 and minus 2, and X will be between 5 and 1. You got it? So this is the rule for expanding the absolute value when with the inequality. But which type? When it's less, not greater. Hello? Basham? Good. Good. So we have minus 1 and 1. This is the half answer. Half of the answer. How? because we are going to sketch a line. We say -1 and 1. Here's the half. I mean, this is the first. The second, well, it's not half, it's one of the three. The second, we should study the boundaries. We say let x be, for example, -1. Number 3, we say let x be 1. Understood? Then, so when you mention x be 1 -1 means that you should put it in the original series. We have what? If you remember that. xn over n, right? This is the original question, right? And we know n start from 1 to infinity. So when you say x to be 1, you should put -1 here instead of x. So it will be changed to what? -1, n -1, -1, n. Let me change that -1 to another color to get the idea. You got it, Jama'at? Because we say let x be -1. So tell me, if you have a to power n, a to power m, the result will be what? A n plus m. بنشيل سنة okay, now. The bases are equal. We are going to add, yes, or exponents or the power. So depending on that rule that I know, so -1 and -1 will be what? Will be 1 -1, 2n -1. Am I right? n 2n and over n the series. So now I got a series without x, right? So we should study that one is converge or diverge. If that one is converge, okay, we are going to fill here. We say include. If it's diverge, we are going to leave it and we are going to the other boundary. So tell me about that series, diverge or converge? Huh? Yalla. Discount 50%. Okay, discount Hisham, welcome. Yalla. In 10.6. Right? 10.6. Okay. So we'll get what? We'll get a, no, I don't think it's 10.6. No, I don't think so. Yalla. Let me substitute. So this power is odd, you know. The power is odd. If I have 2n plus 1 or 2n minus 1, usually you will get odd, right? For example, if n is 1, I will get what? n0, I'll get 1. n2, n1, I'll get 3. n2, I'll get 5, right? The same thing is true for here. If I n0, I'll get -1. n1, I will get what? 1. And like that. So every time you will get odd. So means that this series can be written, because I got what? Minus. Can be written as this series. Am I right? Because that one, that one will give me minus every time for all n. Why? Say 2n plus -1 is odd. فأنا قاعد شيء تاجا يعني مش تواني تاج لقل minus قاعد شيء معناتها negative -1. Clear, dears? So tell me about that one. 10.4 discount. 10.3, sorry. 10.3. I know we skipped. It's 10.3. Tell me about that one's converge or diverge. Why? شوكولاكيتشي بالضبط يا اخوي باش شغل بيناس سوري شوكولاكيتشي is what hello لا ناسيته اوكي وضع موت انديو نايتشيبو يعني يوجا ناقصي اللي تانتي اجاتشي ها by 1 minus you missed everything so it's a harmonic diverge right so by multiplying minus nothing changed because I can say an is equal to like that right so negative multiply diverge you'll get what diverge nothing changed so I'll get negative harmonic series so it's 10.4 10.3 or 10.4 so in that case diverge I got diverge so what do you mean by diverge means that still I am here means that that one exclude right is not include okay number 3 let x be 1 again now will be changed to what right in that case 1 to power n has no value and nothing changed so I'll get what so tell me about the term of here if I put n to be 1 I'll get what so let me see alternative series so alternative is what converge or diverge Yalla, I'll get, for example, n1, I'll get 1. n2, I'll get 1 over n, 1 over 3, 1 over 4, and go on. Three conditions to satisfy it. This is alternative series. We should use alt test, or you should alt, alternative series test. Okay. So do you think that one satisfies 3 conditions? First, 1, 1 over 2, 1 over 3, converge positive and yes. How about that one? Decrease. How about that one? So by alt as converge. So in that case, that one will be my solution. So where's there diverge skipped, there's a converge included. So this is the solution for the first one. You can see from here -1 excluded, +1 included. The blue is the solution. The red is divergence place. The blue is convergence region or place or location, whatever you want to call. You go to Jamaat. It's not hard. Like reviewing from 10.2 to 2.6. So that's good. So I'm going to pause the video. And also pausing the record. Okay. Yalla. Second example, yalla. We should be faster because you know we have many things. So we have minus x to n minus 1. Okay. Now, example number 2, n from 1 to infinity, -1 n minus 1, x to n minus 1 over 2n minus 1. Am I right? Let me just check the power of the -1. Yes, good. So after that one, when you expand that one, you see we have a what? We have a series which is not geometry. Why is not geometry? Because the denominator has got a problem, right? So that's why we cannot say anything. So careful. Now how we solve that one is other, right? Other power series. So we are going to use absolute ratio test directly x 2n minus 1 plus 1, right? No, I'm wrong. We should be careful here. So let me write down first the original one. Here's the original one. You know why. I took a reciprocal directly. And here's the x2 n plus 1 minus 1, 2n plus 1 minus 1. Am I right? That's good. So let me do in its place. So I'll get 2n plus 2 is equal to n plus 1, right? 2n, and I'll get plus 2. Then 2 minus 1, I'll get what? 2n plus 1. So we will get 2n plus 1. Of course, the same thing true for here, right? 2n plus 1. Understood? Well, so how we deal with that one? How we make that one? So I know before that, I know is equal to, for changing, it's better to not change, madam. Now it's clear more. I can change that one to 2, and that one 2, okay, minus 1. It's clear, dears? Just I change x to power 2n plus 1 minus 1 is equal to 2n plus 2 minus 1, because I have 2n x minus, I change it to 2x with plus 2n minus 1. Now you got it, right? Do you have any question? Clear, right? Good. So I'm going to erase that one. You don't need. Make it clear here. Okay. Now it's time to what? To cancellation, right? So equal to x squared 2n minus 1, 2n plus 1. Am I right? And you know, because x squared is positive, we don't need absolute value. Now we have x squared. And that one does not do not again, and equal to what the limit? Equal to 1. So here we are. We can say that one is equal to rho. And we say x squared between 1 and, or you can say just x between 1 and minus 1. Why I can say just x? Yes, because x squared like that. So it will be the same. We see the square root for both sides. So I'll take x squared. We see that we don't need the absolute value. So that one is less than 1. And one of the definition of absolute value is like that. Do you know about that one? And also we have another definition is what? X minus x when x greater than or equal to 0, x less than 0. Absolute value has got two definitions. One of them is like that, and the other is like that. Here we are going to use that one. Understood? Because I need it here. So that's why I say x between what and what. Let me write everything for you again. Before that, I'm going to write the steps for you again. So we say we got x squared, and I know x squared, so means we are going to compare x squared less than 1. And we are going to take x like less than square root of 1, right? And means that x less than 1. And you know about that. You got it. So this is the first part. We got minus 1 and 1 again. That 1 and minus 1 again is not guarantee to every time you have 1. Maybe sometimes we have x minus 1 less than or minus 2 less than 1. You will get something else. So be careful. It's just example. Okay, now first time, this is the first, we finished. How about the second? X be what? Minus 1. So I'm going to put what? Am I right? Okay, I'm going to change what? X to what? All right. So add these exponents together. I'll get what? 3n minus 2. Good. So we got the series 2n minus 1, 3n minus 2. Okay. So tell me about that on converge or diverge. I don't know actually. Actually, I don't know. We should test it. I should expand. We should expand at least some terms. Let me first term. If n is equal to 1, I'll get what? Negative 1 over 1. So it means that we got negative 1. Okay. Second term, still not clear. Second term, if n is equal to 2, 6 minus 4. So even make the positive, right? So positive 1, I'll get what? 1 over 3. And next, I'm sure maybe we get minus. Let me check. N2, sorry, N3, 9, 7, right? So I'll get negative 1. And that one will be what? 5. Am I right? So generally, you can see 7. I think maybe. Check that one. And negative 1 over 9 and go on. Maybe, I don't know. And go on. So we got what? We got what? Alternative test, right? Negative, positive. It's okay. Positive, negative, or negative, positive. What's the difference? So we got alt. So I'm going to apply 3. Yes. First, let me see. Each one. All positive, right? We yes, why not? Is alternated. If we have double, then you are right. We say that before. You remember? In 10.6, when we say we don't care about the minus. If I forget about that one, the terms are positive or not. Yes, but they alternated. So remove the alternative tool, you'll get the positive terms, right? The first. The second, tell me greater. So good. The third, where's UN? I'll get what? You'll get 0. Converge or diverge? You see, if sorry, it satisfies 3 conditions. So by alt, go diverge. Why diverge? Okay. So alt, converge. Okay, so what do you mean by converge? Include, right? So how about 1? I don't know. So we have so let me check, right? Exactly, you get the same. You're right. So you put 1 here, cancel. It's like multiply 1, 1, and nothing changed. So we get again minus 1 over 2n minus 1. And I know that one again, what? Alternative. So is again is converge. Kindly do it at exam, okay? First, second, third, show me. Then, so our solution will be what? Include both boundary, both sides, right? So that's how to answer. Did you understand? Most of the exercises are like that. Some of them like a geometry, and we have some special cases. When I say special, it's not a special to solve. It's a special as a result. What do you mean by that? Look at the third example. You know what I mean. X and n factorial. From 0, better. 1, x, and what is that? Okay, I'm sure about that power series. And 100% is not geometry because we have denominator. Let's make it a math. So how we find? We say limit of absolute value, right? I'm using reciprocal except directly. Sorry. Reciprocal geçiyor. N factorial over xn. Okay. X and x, n plus x, n factorial. You know why. I just expanded and quickly, and we will get what? What's equal to what? جماعة. A result again چی? So in the previous we got absolute value of x, right? Or x squared. But here, what's mean that? That's why I say special case. It's very faster, very quick, and special case. Yalla. Converge to where? You're right. I'm with you, but where? So means that if I put any value of x, does not make a change, right? So for example, this is my row and less than 1 and converge, right? If x is 1, 1 multiplies 0, x minus 1, x anything, even x is 0, 0 multiplies 0 will give me the 0. So it means that every time, for every value of x, there's no period, for every value for x, I'll get 0. And means that every time you don't need to compare anything, don't have anything. Every time your row is less than. So you don't need to test row. In the previous, we tested. Why? Because you got x squared. So what's x? Where is x? It should be here converge or here. We find that between just one, -1 and 1 is converge. But here every time is converge. Everywhere is converge. Why? Because the result of the limit is 0. You got it? This is a special case. So here you are. You can see everywhere. Sorry. Our C for all x. When you say for all x, we mean that here means that x for all real number, or x minus infinity to infinity, or say for all x. Understood? You got it, Jamaat? Okay. Example D. Against n factorial xn. That one also special case. Careful. Again, it's not geometry. Of course, we know we expand, and it's not geometry. Okay, let me solve by an approach. And there is no ratio, right? Reciprocal. So this is the original one, and that one. Am I right? Hello? You know why? That one xn plus an plus 1, that one an. So remains what? and equal to infinity, right? So, and you know, which is diverge, right? So what do you mean? So if I put 1, x be 1, I'll get what? Infinity. So my row will be greater than 1, means that diverge. If it's minus 1, but there is one point has got problem, which is what? 0. Because if I put 0, I will get indeterminate form, right? And you cannot use the elevate on things. So that's why I say all diverge just 1 point, just 0, no interval, 1 point. You can different between 0 and good. So here we are in D. You'll get 0 unless x to be 0. Sorry, infinity unless x to be 0. That's why the only solution is 0. Yani everywhere is diverged except just 1 point, 0. Maybe in your lecture note, exercise will be 1/2 only. So be careful. You should find whatever you want to find. And we see that. We like that and like that. And we mention some regions like that. We see. And also, I remember some of the students ask about the absolute value. Look, we can open it or expand it like that and like that. And here you are, everything is clear. Amanat analysis information. This is very important. Look at here. Look at that one. So we change to R and minus R. R and minus R. Then A to that one, A to that side, and you'll get the result. Otherwise, diverge. So converge and diverge. Good. Now operation on power series, the last thing. If I have two series, how to multiply them? Actually, we need that technique for, or we need that operation for Taylor series. Look at here. If you have two series, that one and that one. So how we expand them, how we make them, summarize them, make them to one. Easy. Try to expand the first one for 3 or 4 terms. The same thing true for the second series. Try to expand them 3 or 4 terms again. Then multiply the first one by all, so you get the same. Then multiply the x to here, so I'll get x squared, x cubed, x to power 4, you can see. And 3 to him, so x to power 3, x to power 4, x to power 5. And then compare. Compare what? Now I have just x with nothing, right? Now I have just x. So I say I have x and yes, how about minus x squared and x squared? Now I have minus x squared over 2 plus x squared. You know, common denominator will be 2. And I'll get what? Minus x squared plus x squared, 2x squared, and I'll get 1/2. You know. Sorry for the first. So here we are. So that one here, and that one here. And how about x to power 3, x to power 3, x to power 3? So I have x to power 3 minus x to power 3 over 2 plus x to power 3 over 3. So common denominator will be 6, and I'll get 6x to power 3 minus 3x to power 2, 2 plus x, and you'll get 5/6. You got to Jamaat. Just multiply. So when you say multiply, do not surprise, do not stack, just try to multiply one by one, one for all, second for all, third for all, and you get a result. We finished here.